Partial fraction decomposition is when you take an expression like this and try to turn it into the sum of two fractions. If you think about it, for these fractions to have a common denominator of x minus 2 times x plus 5, it's reasonable to think that separately one has the denominator x minus 2 and x plus 5. And partial fraction decomposition is when we figure out what the numerators would have to be so that the sum of these two fractions becomes 10x plus 29 over x minus 2 times x plus 5. And there are two different methods for doing this, and they both start the same way. They both start by multiplying both sides of the equation by the common denominator. When you do that, you get 10x plus 29 on the left. On the right, if you put when you put the x minus 2 times x plus 5 over here, just to show you, the x minus 2's would cancel out. You'd be left with x plus 5 here. And the same thing over here, except in this one the x plus 5's would cancel out. You get b times x minus 2. And this expression here is going to lead us, we have two options from this point, option 1, option 2, and these are the two approaches to complete the question. So let me write down what we have there. 10x plus 29 equals a. The a had the x plus 5, and the b had the x minus 2. So method number 1 goes like this. You distribute the a through and the b through, and then you combine the like terms, which by like terms, I know there's a lot of variables here, but the x terms, so ax plus bx is a plus bx, and the 5a minus 2b, those don't have any x's, so they kind of end up over there. And then we do a system of equations, because the a plus b is the coefficient of the x, so that means that a plus b must equal 10. And the 29 is this other stuff. So 5a minus 2b equals 29. System of equations, I like to multiply both sides by 2. Add them together, 7a equals 49, a equals 7, plug it into a plus b equals 10, b equals 3. So that means that this partial fraction decomposition ended up being 7 and 3. And you could test by adding together 7 over x minus 2 plus 3 over x plus 5, and you will get 10x plus 29. This is an important technique in calculus because there are times where we're trying to do something with an expression like this, and if we can do a partial fraction decomposition, we're able to do the pieces which are simpler to work with separately. Now there is a second method. And the second method begins, just like the first method, with multiplying both sides to get rid of that big denominator. But the way the second method works, and the first method is called the equating coefficients method, and the second method is also called the convenient values method. And the way it works is, you look at what would make this expression to be 0. So if you plug in, if x was 2, that would make x minus 2 0. So you let x equal 2 and watch what happens. Put 2 in place of all the 3 x's in the equation. You get 10 times 2 plus 29 equals a times 2 plus 5 plus b times 2 minus 2. But that's the same thing as 0. 2 minus 2 is. So we get 49 equals 7a, and a equals 3. that what I had? Hold on. No, because 49 divided by 7 is not 3, it is 7. And as far as the b value goes, for that one, you let x equals negative 5 in place of all 3 x's. What that will do is I get negative 50 plus 29 equals a times 0 plus b times negative 7, which is negative 21 equals negative 7b, and b equals 3. So whether you use the equating the coefficient method or the convenient values method, you get the answer 7 and 3. Now the convenient values method might seem a little bit like we're breaking some rules of math, because 2 and negative 5 are the very values that would make the original equation undefined. But there is a complicated explanation for why that works that's not going to be part of this video. For this video, as long as you can do the two methods, you've learned what I wanted you to learn for this video.